UCS and N5K are 100% exact in terms of QoS. They are exactly the same in terms of features. That means a system-wide queuing and MTU configuration. Per port, I do marking of traffic. So per port, I can do my marking. So setting CoS bits, setting DSCP bits, doing all that stuff. On the N7K, even crossing VDCs, I have a system-wide queuing configuration. So the queuing configuration and the queue differentiation is system-wide, even for all VDCs. So even the N7K only supports a system-wide queuing configuration, where I can do a per port marking, but also an MTU size per port. So I can set the MTU size in the system-wide QoS policy, but the port MTU will take is a more specific configuration, so that will be the one that is going to be active. So two main differences. In the N5K, I configure MTU system-wide. On the N7K, I configure MTU per port. That's actually the biggest difference in the two platforms. For the rest, in terms of configuration, they're all pretty much the same. And let me walk you through a small configuration of that. So if I take my Nexus 5K, I'm going to enable the FCOE feature because that changes your QoS policy at the first place. So things that you can't change on the N5K and 7K in terms of class FCOE and class default. Let me run you through that. So the best thing to verify your configuration is do a show policy map system. That will show you all the QoS policies that are applied to the system at this time. So the network QoS configuration, what that determines is how does my queue behave in terms of MTU size and in terms of priority flow control. So the pass no drop means enable priority flow control into this particular queue. Then there is an input and an output queuing policy. In that queuing policy, what I'm doing there is setting bandwidth percentages. So bandwidth reservations, class-based weighted fair queuing, bandwidth reservations that I do, nothing else. And then finally, that third map is a QoS policy. The QoS policy is my marking policy. So what this is going to do is match on a certain CoS value and mapping that to an internal mapping. So if I take that and diagram that, so if I have a Nexus switch, traffic is coming in on a port. On this port, I have a QoS policy map of type QoS. So policy map type QoS. This is my marking QoS policy. What I do here is I match traffic based on their requirements, so either IP address, port numbers, or matching on CoS values and DSCP values. And what I'm going to set here is a thing called QoS group that QoS group configuration is not a flag that I set in the packet. Now that is something that I use internally to keep track of the packet when it's exiting the switch again. So this QoS group is just an internal group because on the outside I do not want to go through the process of checking the marking again. I do not want to go into the packet and check its marking. No, I just want to trust on some internal flag that I set through for this particular packet. So QoS group is always local inside the box significant. It's not a marking in the packet. Then internally, in my ASIC that I run here for my system, or multiple ASICs, I have bandwidth reservations, so 50% for that, 20% for that, and so on and so on. And I set things like MTU size and priority flow control. The bandwidth reservations go into the queuing policy map, and the other things go into the network QoS settings. So those are the three types of policies that I have: QoS, queuing, and network QoS. They all use their own class maps, right? Because that's how the process works. I have a class map, I have a policy map, and then I apply the policy. This is done system-wide, system QoS, and then I apply the service policy. These ones, I specify them separately for QoS, queuing, and network QoS. Policy maps, just the same way. QoS, queuing, and so on and so on. And I have a special class map for control plane policing. Now, things that I cannot change are the default policies. So when you get asked on the Nexus 5K, so let me go into the QoS configuration. And what I do is just take normal configuration, just enabling jumbo frames on the best effort class. That's the most common change that I need to do. When I go to my CLI now on the Fabric Interconnect and see what that did, I don't really find DCNM useful for anything when configuring in the data center lab. If you think that DCNM can help you with anything, go ahead and use it. There will not be any questions about it. It will only be there for your convenience. So, in terms of this configuration, what I can just do, if I want to enable jumbo frames on the N5K, let's consider ourselves, we want to enable jumbo frames on the Nexus 5K. So what we do then is take this policy map, take a notepad, and type it in. Now, what you change here is that in a policy map, there are no matches. So this is something that they take from the class map. That's something I remove. You see that I enable flow control here. Maybe I do, maybe I do not. What it means by the 8Q and 7Q configuration is nothing else than everything that doesn't match the FCOE queue falls into the default class. That's actually the default QoS policy on the Nexus 7K. So when I log into my Nexus 7K, let's first boot up these guys. That's the default CUP policy. Let me first boot up the modules. But What that 7 and 8Q policy is saying is anything else than the default class is going to match another class. So this is considered, so like this is the default FCOE class on the Nexus 5K. This is a 7Q policy. 7Q drop and 1Q no drop. That's the equivalent on the Nexus 7K. That's exactly what this is. Because I have 1Q now for FCOE, meaning that supports no drop, then the other 7 will fall into the class default. If I enable the 6Q policy drop and 2Q no drop, it's just going to create an extra class like the FCOE class, match another COS value, and use that. Well, enabling feature FCOE will not add any new queues. Yes, it does. But it will do automatically. So if I disable the FCOE feature, and I do a show policy map system, it did not remove the FCOE queue. Let's log into another switch. Where I did not enable FCOE yet. Here you can see I did not enable FCOE yet, so the QoS policy does not have an FCOE class. So all it does when you enable FCOE is this. It adds the FCOE policy or FCOE class to the default policy. Coming back to configuring a QoS policy, like I said, I like to copy and paste. So I just want to highlight the configuration of your own QoS policy. Like I said, we need to configure a policy map to enable jumbo frames, for example. So I take my default configuration like that, and the question says enable jumbo frames. So I take that default policy map configuration. If I want to enable, let's say, jumbo frames on the Nexus 5K, I take the default policy, that's this one. I remove all the match configurations because the matching is of course related to the class map. That's not the case here. So I need to change the MTU size. We're going to change that to 9216. Now when I copy and paste this, the system is going to warn me that I cannot change the default policy. So let me just think of a new name. So RIX Network QoS policy. So I just created my own Network QoS policy that is using the default classes, right? So I'm using the same class FCOE, class default, and I can copy and paste this into my switch. And now I can go into System QoS, Service Policy Type Network is going to be the RIX NQ policy. Show policy map system type actually. And now you see that I created my RIX policy with jumbo frames using the same default classes. So let me focus on the verification of our UCS iSCSI boot, right? That's where we wanted to focus on earlier. Did our iSCSI boot succeed? And did the firewall channel boot succeed? So let's first check that on the CLI. So let's log into our Fabric Interconnect and see what it did. Oh, connect NXOS A. Show NPV status. I see that I have a VFC interface up and running. So that means that I have at least one virtual fiber channel interface running. So I have at least one guy up and running. Show NPV floggy table. I see that the server interface also performed a flaggy, and that the server interface is now pinned to an external interface, so the NPV side is working. If I check my MDS1, I see a flaggy in vSAN 100 for what kind of port worldwide name? The one that has AA in it. You see that? That's what we configured right in our pool. It says AA here. Now it did not work, or did it work actually? Show zone set active. It did not work because I did not create a zone yet. So I did not create a zone yet for my fiber channel boot device. So let me do that first. Zone the disk that we want to use and zone the initiator. That is my UCS server. Activate it. And now I see that AA guy. So let's figure out the networking configuration. Let's go back to our UCS manager that we have right here. And let's check the KVM console of the server. And let me reboot the server. Actually, let's just use Control-Delete to reboot the server. Now let's see what this all configured on Fabric A. So I see that I have 5 virtual Ethernet devices. One of them is using the 2100 VLAN. Remember what the 2100 VLAN was? That is my FCOE VLAN.